So hello, assalamu alaikum. My name is Madhavan. Today we are going to discuss about the topic of chemistry, which is orbits, suborbits, and orbitals. Firstly, we must know about the what are the orbits. Firstly, we'll draw a diagram of atomic of atom. You can say. So here we have a nucleus, and here we have the orbits. These are called the orbits. Okay. Remember one more thing that previously when we discussed about the orbit, so we can denote these orbits with like two methods. One method is numerical and one method is alphabetical. So alphabetical how? So we can denote these like K, L, M, N, O. Okay, and how the numeric 1, 2, 3, 4, 5. Okay, numbering and alphabetical. I'm just writing A here. Okay. So if you wanna find that how many electrons does the orbit is carrying, so obviously every orbit is carrying different electrons. So you just write here 2 and square. So like if I solve this solution, 2 bracket, if I am taking like m, if I take m square, sorry, not m, we'll write numeric because it is n. So we'll take the square of 3, which will become 9, when 2 multiplied by 9, which is 18. So here we got the answer that m contains the 18 electron. Okay, remember one more thing, that these are dimensionless, sorry, these are non-direction. Okay, it does not contain any direction, doesn't have any kind of direction. Okay, now we have second topic, suborbits. Okay, suborbits. Okay, so basically what are suborbits? Basically these are the parts of the orbits, okay, which named as S, P, D, F, and we have numbered these S, P, D, F, like you can say suborbits as L, like L is equal to 0 is equal to S, L is equal to 1 is equal to P, L is equal to 2 is equal to D, L is equal to 3 is equal to, okay, F. Right then, you must remember the numbering of that. Firstly, we'll take 2. Okay, in S, in suborbital S, it contains only 2 electron, then plus 4 here 6, then plus 4 here 10, then plus 4 here 14. Okay, and remember one more thing, that these numbering start with the whole number. Okay, and the formula for that, like how, like which suborbit is carrying large electron, which suborbit is carrying more electrons. So we have also a formula which is like this, 2 bracket 2 L plus 1. Okay, so we need to solve that obviously, 2 and 2. So we'll take L, which one is L? So here we are taking, for example, if I take 2, so I am just writing here 2. Okay, then bracket plus 1. Okay, so we'll multiply that, so it will become 4. 4 plus 1 is equal to 5. 2 multiplied by 5, so is equal to 10. Okay, so we took the suborbit of third number, like D, which was the which contains this 8, which contains the 10 electron in it, and we have done that. Okay, now what next we are going to do, basically we are going to name these orbits as suborbits. Like for example, if I am taking here 1K, okay, 2L, 3M, 4N. Okay, so we'll just like we just fill these like orbits as suborbits. So firstly we'll take S, which contains the 2 electron in it, and here we'll put 1 because it is the first, it is the first suborbit we are taking. Okay, when we talk about the 2L, so it will contain 1 S square 2P. Now why we are writing 2P? Because P is a second one. Okay, so that's why. Now third one, 1S square, okay, 2P power 6, and 3D power 10. Okay, this is how it works. Okay, and talking about the first, so obviously 1S, 2P6, 3d power 10, and finally 4f power 14. So this is how this is how we write that. And these are orbits, these are the suborbit, which are the parts of the orbits. In further videos we'll discuss about all the things, that how the like suborbits lie on the axis and everything. We'll discuss about every single thing about it. Okay, now remember one more thing about the subparticles, that these are these contain the shape. Okay, so we have S, so what does that S mean? We have P, so what does P means? We have D, what does D mean? So these are the things. So firstly we'll I have to write here for the meaning. Firstly we'll talk about the S. So what is S? S is basically, its shape is very sharp. Okay, it is very sharp. It, like you can say, it's a line by this, it's a line like this. Okay, P is equal to principal. Okay, so what is principal? Now what is principal is basically a thick line, or you can say a big line like this. Okay, and talking about the D, so basically D is equal to diffuse. Okay, which has a little bit complicated diagram like this, like a image is going here, it reflect, then came here. Okay, and the F is equal to means fundamental, 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 complicated. Okay, basically it is complicated because you cannot understand this diagram. So firstly a scientist came and put here, for example, if we take 4n. Okay, if we take 4n, it contains the 32 electrons, and we pass through that from a machine, from a instrument which is called a spectrophotometer, spectrophotometer. And here we have a screen. So if we pass through that, so we'll get what we get: a small line which is can be sharp, which is obviously sharp line, a big and strong line, like big and, or you can say thick line, and the complicated line like this, and nothing. Like you will get, but you will not be able to understand the F, because it is S, it is P, and it is D. So how can you be able to find F and while like until you do not get it perfect? Like if I said it is fundamental, it is complicated. So that's, these are the things which is very important in the atomic structure. You must know about the orbits, suborbits, and its conditions. So today we have already discussed about the orbits, suborbits. That's it. In next video we'll discuss about the orbitals and everything. And remember one more thing: these are dimension. Okay, like not direction. These are the suborbit. These suborbits contain the direction. It is direction. Like it is not non-direction. Okay, it does contain the direction. Okay, so I hope you all understand. Thank you so much.